Hey, welcome back. So we're going to be working on the first part of transformations. This is translations. Let's go ahead and get the notes knocked out of the way. You should have your cutouts. I'm still waiting for them to print, so I don't have mine. But go ahead and take a moment to pause this video right now while you update your table of contents. All right, so there's the table of contents updated. I need to put in the page number, so don't forget to do that for your notebook. I'll be doing that off camera in a little bit. We're going to flip to the first section that we've got going here. All right, so we had our distance, which was the last thing that we worked on, and you want to leave your KWL space for that assignment. That was code, what was this distance? Yeah, C9L2. And then y'all just took a quiz, so you want to leave a KWL for the quiz for that section. All right, and so my notes are going to begin here on this very next page. So pause the video right now. Make sure that you update your title and objectives. They're found over here under the La Feria logo to the right of the video screen. Pause it now. All right, welcome back. We're going to go ahead and get started with our notes. And the first thing that you need to do is find the cutout that looks like that. Since I was waiting for it to print, I've got it floating here on the screen. I want you to get that, and I want you to put that right here in your notes. Go ahead and pause that now while you get that updated. All right, welcome back. So we have our translations description. I'm going to go ahead and zoom in, and it's going to look a little weird as I work on doing this. I just want to read this out for you. Whoopsie. Let's not move that. There we go. That's the thing I wanted to move. All right, I'll make this a little bigger just so that we can see it. We've got some translations descriptions, and so we're starting with this, and then I'll go in and define the word translation in a moment. So translations descriptions describe how things move. We can move horizontally. That's going to be left or right. So it's going to be left or right, or horizontal translation. We also have a vertical translation, which will be up or down. Now the question becomes, how do you know which way you're going to translate? And that is right here in this text box. So, oops, my finger kind of goes under it. Here we go. So looking at this first line, if the value of h is bigger than 0, which means it's some sort of positive number, then we're going to translate that object to the right. It's going to slide to the right-hand side. If h has a value that's less than 0, we're going to move to the left, like that. If k is greater than 0, we're going to move it up, and if it's less than 0, we're going to move it down. All right, let's go ahead and get the last of those definitions in. So you have this glued in here on your notes. I'm going to go ahead and get rid of it for the moment. I'm going to leave myself a space here. So you've got that here, and then we're going to write down here. Now you heard me talking about translation, we're going to move things, but let's go ahead and get the formal definition of what it means to do a geometric translation. So a geometric translation is some sort of slide, and it's in one dimension. So you're either going to slide left or right, you're going to slide up or down. So that's what a translation would be, like my fingers moving across the page left or right, or up and down. And those descriptions that you have in your notes now right above this help you decide which way you're going to translate. Now when we're talking about translations on a coordinate grid, we're going to have something called the translation vector. And before we get to this one big word, I want to take a moment to talk about what a vector is. So, a vector is it tells is a line segment, or rather, excuse me, it's an array that gives a direction and a distance. So then our translation vector then is going to be the vector that tells us what direction we're moving and how far. So the translation vector is going to be the vector describing the translation, how far we're moving and in what direction. Now vectors are written very special ways, so we're going to take a moment and we're going to look over that real quick just so that you have it in your notes. And we're going to start with our coordinate grid. So here's our coordinate grid. And say we have some point, I don't know, here at 1, 1. And we're going to move it from 1, 1. We're going to move it so that it ends up at 4, 4. I'm just making stuff up, but I'm not sure where it is. Okay, so it changed. It moved in this direction, but on this grid, we can't describe a diagonal motion. We can only describe left or right motions and up and down motions. And so we need to think about, how did the coordinates change? So we started at x equals 1, and we ended at x equals 4. So our change was an increase of 3. And so this is our h value. So that means that we moved to the right, we translated to the right 3 units to get to 4. Looking at the y's the same way, we can see that we also have a vertical translation of 3. And so k also equals a positive 3. In vector notation, that's going to read 3, 3. But notice very carefully the brackets, please. When we're talking about the location, where the points are in this plane, we use the round parentheses. But now that we're talking about a vector, this gives us a distance and a direction, how far and where we're going. These parentheses are turning into almost a less than equal sign looking thing. Okay? When we come to class tomorrow, we'll do some examples. We'll play around with moving stuff around. So be ready for that tomorrow. Thanks, and we'll see you then.